Today I'm going to show you how to set up a 3D character model from Mixamo as a third-person character in Unreal Engine 5. If you're not familiar with Mixamo, it's an amazing free resource where you can download any of dozens of character models and thousands of animation sequences that you can apply to any of those character models. And this is a resource that's provided by Adobe. They purchased this project up a few years ago, and I don't believe there's any more current development going on, and they've just made this available for free to the community to use. So for this video, I'm going to select Astra, and that's the name of this character. I found Astra here on page 2 near the bottom. It might be different for you depending on your screen resolution, etc. And so to start with, we're just going to download the Tpose. If you haven't been looking at any animations yet and you just select a character, you'll be already on the Tpose. And if you have been looking at some animations, you'll be on a different animation, so you'll need to search here for Tpose and find that and select download. And so now if it just says FBX and Tpose, that's fine. If you've been looking at animations, you'll have a couple other options here. For this download, we want to say with skin. I've selected 60 frames per second, doesn't matter, there are no frames. And keyframe reduction is none. And go ahead and click download. Okay, we need a couple of animations to get started as well. We need 5 in total, and the first one we're going to get is idle. So I'm going to search here for idle, and this is going to be when your character is standing there, not walking. So I'm going to select something like this one here with the hands at the side and a bit of a breathing motion and some posture, stance shifting. And so for some of these animations, you can actually change some of these features of the animation. So for this one, I can use this slider to adjust the posture, the amount of the breathing, the stance shifting, and pretty well all of these animations have an overdrive slider. It'll be defaulted at 50, and it basically just lets you speed up or slow down the animation. In the case of an idle animation, it doesn't make much sense to speed it up or really to slow it down for me, so I'm going to leave this at 50. And character arm space is also a slider that appears on pretty well all of these animations, and it's going to let you adjust for different models, different sizes of midsections and arms. So even this model here, I can see the thumbs here just grazing the hips and clipping through, and I can actually increase the arm space a little bit here. And now we have these hanging at a more comfortable position, maybe even out a little too far, so I'm going to just adjust these to maybe 53. Okay, maybe 54 or 5. And so I'm pretty happy with this. You don't have to fool around too much. And I'm going to download this idle animation. So for the animations, I'm going to do the same settings for all of them, and it's going to be an FBX, of course, and it's without skin, and 60 frames per second, and keyframe reduction is none. And then go ahead and download. Okay, the next animation that we need is a running or a jogging or walking animation. You can really choose from any of those. I'm going to find a jogging animation, something medium speed, let's say. And so, of course, there's so many of these to choose from. Sometimes it's hard to find just a basic one. You know, I don't want to be stumbling or something like this. I just want to jog forward. Okay, so this seems pretty decent. I'm going to scroll, zoom out here a bit in my preview window, and I need to make sure for Unreal Engine without root motion, for a traditional animation, we need to select in place. So all our animations are in place on the spot like this, and this looks pretty decent. I could adjust the arm space a little bit, but I don't think I need to. So I'm going to leave everything the way it is. And maybe I'm going to slow it down a little bit. It's a little quick for my liking. I'm going to take overdrive and slide this down to 40. Maybe slide it to 30. Maybe 35 should be perfect. Yeah, I like that pace. Okay, so I'm going to go ahead and download this one here. And same settings here, without skin, 60 frames, no reduction, and download. Okay, the next animation that we need is for jumping. So I'm going to search here for jump, and there are really an enormous amount of different jumping animations available. So what we need in particular here is not a single full jump animation. And the reason why, okay, let's say you picked an animation like this. So it has a specific time that the character is in the air. And although you could change that a little bit with overdrive, really if you slow this down with overdrive, instead of a normal jump that lasts longer, it actually looks like a slow motion jump. Just the movement of the character is, looks slow motion. It doesn't really work to slow down or increase your jump animation. And so you have this sort of fixed amount of time that the character's in the air. It doesn't really work for a game where you could be jumping, let's say, from a higher spot to off of a ledge or something like this, and you might be in the air for longer than if you did just a jump from the ground or something like that. Excuse me. So the way they implement jumping where you could be in the air for a variable amount of time is by splitting up this animation into 3 separate parts. And so I'm going to search here for jump up. And this jumping up animation, this specific one is it's just called jumping up from Action Idle Game Blend, it says. Okay, and so this is the initial leap off the ground, the very first action of the jump. And if I look here for jump down, this one here is the landing sequence for the same jump. And if I look for, I believe it's called falling idle. And yes, here it is. This is the loop section of the jump where the character is in the air for whatever amount of time it may be, depending. Maybe you're jumping up onto a ledge and you're going to be in the air for a lesser period of time than if you weren't going to land on that ledge and you were going to land all the way back to the ground, or the opposite, you're jumping from something you're already in the air higher than the ground, you're jumping all the way down to the ground. Okay, so let's get started by downloading these 3 animations. I'm going to download Falling Idle, and I'm going to rename this later. I'm going to call this Jump Loop. So I'm going to download that. Okay, and I'm also going to download that jump up animation, jumping up. And I'm going to also download the jump down animation. Jumping down. Okay, perfect. Okay, so now I've got my character model downloaded and my 5 animations. I'm going to go ahead and switch to Unreal Engine 5. Okay, so I've launched Unreal Engine here and just made a new blank project, and I'm going to import the 3D model that I downloaded from Mixamo. So I'm going to right-click in the content browser, new folder, I'm going to call it Astra model. And I'm just going to drag in the FBX file that I downloaded from Mixamo. So I'm going to make sure I have all these default options selected, and under search location, it's going to be local, and material import method, create new materials. So the files from Mixamo, the FBX file, contains all of the textures for the model packed into the file. So with these settings, it's going to unpack those files and create those materials for you and apply them to the mesh. Okay, we can see all the textures it's made here and the materials here. And first thing I'm going to do is drag out my model, one of these skeletal meshes, and just take a closer look. And a lot of times we'll notice a problem. So for me, I'm noticing a problem with the hair. And you might notice something else, maybe the eyes or the mouth or some other feature. And what's happening here is 99% of the time we need to change a material from translucent blend to masked. So you need to figure out which material is the culprit. In my case, it's this hair material. So I'm going to open that up. And the result node for the material here, I need to change the blend mode from translucent to masked. And I also need to change the input pin here. Instead of RGB to opacity, we'll get rid of that. And I'm going to plug in alpha to the opacity mask. All right, we'll save and close. And now I've got my hair looking right. And so that'll fix basically 99% of the problems you'll run into with a material. It's just setting it up automatically as a translucent material, and we need masked. Okay, so with that out of the way, we're going to set up a character blueprint. So I'm going to select this and delete this mesh. I'm going to go back to my content root folder, right-click, and make a new blueprint, and select character. I'll call this Astra char. And I'll open that up, and I'll select the mesh component, and I'll set the skeletal mesh to sk_astra. And now I need to adjust the rotation and the location. So I'm going to set the rotation here, the Z value, to 270. And so now we're facing forward. Forward is the x-axis, or the way that this arrow component is facing. And so you need to adjust your models to be facing basically the same direction as this arrow. And so now I'm going to lower the model down a little bit into the capsule here. I need to change the Z value of the location, and I'm going to put in -90. All right, now I need to adjust the size of this capsule a little bit. I'm going to select the capsule component, and the capsule radius by default is 34. I'm going to change that to 24. All right, so that fits a little better now, and I'm going to compile and close that. Now if I drag one of these characters into the scene, we're pretty much in the same spot as we were at the skeletal mesh there. We have the Tpose, and we don't have any controls or anything set up yet. So what I want to do is set up the, I want the player to possess this character when they start playing. So I need to go to the details panel, type in possess, and under auto possess player, I'm going to select player 0. All right, now I also want the player to have a follow camera. So if I hit play right now, for example, I think it's just going to give me a default camera. Yeah, I can see the back of the eyes and the nose and mouth here, and it's just put the camera directly in the head here because we don't have a camera assigned. So I'm going to make one. I'm going to open up the character blueprint. Open the full blueprint, go to the viewport, and I'm going to add a component and add a spring arm. So I've got this red line here. This is a spring arm or a camera boom. And now I'll make sure I have spring arm selected, add another component, and add a camera. All right, so I've added this camera as a child of the spring arm. So if I were to grab the spring arm, let's say I move this around, it moves the camera along with it. Or if I rotate it here, it swings the camera along. And so now we can control our camera using the spring arm, and we can, when we press play, we're going to be viewing the back of the character here through this camera. All right, perfect. So now I need to set up some controls. Right now, if I move my mouse, nothing's happening, and of course I have no keyboard controls. We haven't mapped anything yet for controls. So let's get started on that. And the first thing I'm going to do is go to Edit, Project Settings, and find Input, and I'm going to define some bindings. So I'm going to make a couple of axis mappings here. I'm going to press plus twice, and I'm going to name these mouse pitch and mouse yaw. So these axis mappings, when you make a new mapping and you name it something, I can now drag out an event on my character blueprint called mouse pitch or mouse yaw or whatever you named it here. And that event is going to start some sort of logic that you want to happen when this event happens. And so just below these event names, I can assign which inputs that I want to invoke these events. So for mouse pitch, I'm going to type in mouse Y, and that's going to be the up and down value of my mouse movement. So that's going to invoke the mouse pitch event. And for mouse yaw, I'm going to type in mouse X. And so now that's going to be my side-to-side movement of the mouse. And that's going to invoke the mouse yaw event. Okay, so I'll close this, open my character blueprint, and on the event graph here, in an empty spot, I can right-click, and I can type in mouse pitch and get this event node. And below that, I'm going to right-click and type in mouse yaw and get that event node. So what I want to happen when we move the mouse is I'm going to right-click and say add controller pitch input, and connect the execution pin here and the axis value. So the axis value is going to be essentially for mouse Y, which is up and down. If you move your mouse up, you're going to get a positive value, and if you move your mouse down, a negative value. So we're just going to feed that value directly to this add pitch input node. So we're going to change the controller pitch basically directly by the amount that you're moving the mouse in the up or down direction. And we're going to do the same thing for the yaw, but I'm just going to add controller yaw input. And we'll connect that up. Okay, so now if I press play and I move the mouse, let's say side to side, I should be adding yaw input to the controller, which is in rotation on the z-axis. So we'll see here what happens. And yes, I'm able to rotate the controller, which rotates the character, which rotates the camera. So this isn't actually the behavior I want, though. I want to be able to look around the scene. I want to orbit around the character as a pivot point with the camera. And I don't want the character to rotate like this as I'm moving. Like the feet aren't even moving or anything. It looks completely unnatural, right? So I need to make a couple changes here. And I'm going to open back up the character blueprint. And I need to find in the details here, I'm going to search for rotation. And I'm going to find under pawn, use controller rotation yaw. And I want to uncheck that. So I don't want the pawn to use the controller rotation. And I want to select the spring arm and find use pawn control rotation. And I want to select that. So now I'm telling the spring arm that I want it to use the current rotation of the controller. So when we add pitch or we add yaw to the controller, it's going to inherit that by using the pawn control rotation, the spring arm, the root of the spring arm is going to also pitch and rotate. And that's going to cause the camera that's connected to the spring arm, obviously, to swing around. Okay, so let's check it out. And now, yes, when I'm rotating the mouse, when I move the mouse side to side, the character isn't rotating. I'm actually orbiting around the character. I can go all the way around to the front. And the only thing I'm noticing that's a problem for me here is the up and down movement. For me, it's seems to be inverted. So for some people, this is a matter of preference. For some people, this might feel natural. And of course, it's hard for you as the viewer to tell what's happening. But for me, it feels inverted. I want to change the behavior to be reversed. So I'm going to go back into Edit, Project Settings, and Inputs. And for this mouse pitch, I'm going to change the scale. So the scale right now is positive 1.0. I'm going to change this to negative 1. And that's going to invert the behavior. It's going to deliver a inverted axis value to that event node. So now if I close that and hit play, okay, that feels natural. So for me, this feels right. And now I can orbit all the way around the scene and look at whatever I want. And the character is in the center of my view. Okay, so the next thing I want to set up is actual movement of the character. And so we'll use the typical inputs W, A, S, and D. And I'll get started on that by going to Edit, Project Settings, Input. And I'm going to set up 2 more axis mappings. And I'm going to call these Move Forwards, and Move Sideways. So for these axis mappings, we can select more than one input. I'm going to add a second input, and we're going to set for move forwards, where inputs are going to be the W key. So I'm going to type W, find W here under keyboard, and S. I'm going to find S under keyboard. And we just want to set the scale values here. So W we want to be forward, which can be, say, positive 1. And S we want to be the invert of that, the inverse. We're going to set that to negative 1. Move sideways. Okay, so I'm going to add another input here. And we're going to set this to D on the keyboard. And D will be for moving in the right, toward the right. So we'll leave that as a scale of 1. And we'll select A for the other input. And I'll find A here under keyboard. And that's going to be to move left, or the inverse of right. So I'm going to set this to -1. All right, so I'll close that. And now I need to open my character blueprint and find a new empty spot here. And I'm going to right-click and type Move Forwards and grab that event node. And underneath that, I'm going to right-click, type in Move Sideways, and we'll get that event node. And I'm going to drive this logic with some of the similar nodes. So I'm going to just right-click in the middle here and type Get Control Rotation. So this is going to get the current rotation of the controller. When we're adding pitch here and yaw with the mouse movement, we're moving the controller, rotating it, and so we can get that rotation with this node here. And so based on which way that we're facing, we're going to get a forward vector to figure out which way is forwards. So if we've got the camera angled a little bit off to the left and you start moving forward with W, your new forward vector is the way that the camera is facing. And to do that, we need to take the rotation value. I'm going to split this pin so we can get the individual roll, pitch, and yaw. And I'm only really interested in the yaw. We don't need the roll or the pitch to figure out the forwards vector. So I'm going to right-click here and make a rotator. and I'm going to plug in only the z value. So we're stripping out the x and the y, and we're making a rotation value that's going to have 0 for x, 0 for y, and the actual value for z. And from that return value, I can say get forward vector. And from here, I want to, this is going to give me essentially the forward vector from wherever the controller rotation is currently facing. I want to get, I want to move the character in that direction. So I'm going to right click and type add movement input. There we go. Okay, so add movement input, and we want to move in the world direction is going to be this forward vector. So I'll drag that to there, and I'm going to plug in the execution node from the move forwards event. So when we press W or S, this is going to fire this event, and it's going to add movement input in the current forward direction, and the scale value is going to be driven by this axis value. And so remember, this axis value, if we pressed W, this is going to be a +1, and if I pressed S, it's going to be a -1. So it's going to move on the forward vector positively if we pressed W, which is forward, of course, and it's going to move on the forward vector negatively if we pressed S. So instead of moving forward away from us, away from the screen, it's going to move towards us. And so that's the move forward logic. Now I need to set up the move sideways logic. So this is for if you press A or D. And so what we want to do here is, instead of the forward vector, I'm going to drag off of this return value and say get right vector. So this will return the vector that's the right angle to our current forward vector, the way we're facing the camera. And so if we've pressed D, we're getting a positive axis value, and so we want to move on this right angle vector positively. So I'll say add movement input. I'm going to control W here to duplicate this node and plug in the execution here. And we're going to move in the direction of the right vector, and the scale value will be this axis value. So now D will be positive movement on the right angle, and A will be negative movement on the right angle, or in other words, moving left. Okay, so that's it. We're all set up here. Now we need to test it out. Okay, and I'll try moving around here. And okay, perfect. I can move forward, backward, and left and right. But the character is facing forward no matter which way I am moving. And so I need to make one more little adjustment here. I'm going to open up the character blueprint and select the character movement component. And in the details here, I'm going to search for orient. And here where it says orient rotation to movement, I want to check that. And so that's going to rotate this character towards the direction of acceleration. And you can adjust how quickly it's going to rotate using rotation rate. So I can search here and find rotation rate, and by default it's set to 360, which is per second. This is a rate change in rotation per second, so it's set to rotate one full 360-degree turn in 1 second. So it's a fairly quick turn, but not so fast that it's instantaneous. So you can adjust that up or down if you want to change how quickly the character is turning. So let's check it out here. Okay, forwards, backwards, all right, and side to side. Now we've got the character rotating to face the direction that we're moving. So this is perfect. The last thing we need to set up is the actual animations for idle and walking, and then ultimately for jumping. Okay, so I'm going to press escape here, and I'm going to start by setting up an animation blueprint. So I'm going to right click here, and I'm going to go to animation and select animation blueprint, and I'll select the SK Astra skeleton. Click OK, and I'll name this Astra Anim BP. Now I have to open the character blueprint and indicate that we want to use that animation blueprint. So I'll select the mesh component, and under animation here, under anim class, I'm going to drop down and find the Astra Anim BP, and we'll compile and close that. Now I'm going to make a new folder and import the animations that we downloaded from Mixamo. So I'm going to call this folder animations, and I'm just going to drag and drop the 5 animations that we downloaded. So I need to select the skeleton that these animations are going to be targeted to. So I'm going to drop down, select SK Astra skeleton, and select import all. And so, by the way, I also renamed my animations, so you can do that if you want as well. I called them jump start, jump end, jump loop, and idle and jog forward. So to start with here, we need to make a blend space. And so I'm going to right click, go to animation, and make a blend space 1D. And I'll select the SK Astra skeleton. And I'm going to call this idle jogging blend. And so this blend space is going to control our animation between the idle animation and jogging animation. So I'll open this up, and the way that this works is we can use this graph down here to blend between 2 animations or more based on a value. And so this value at the bottom here is currently, the name is set to none. We can set a name over here by going to horizontal axis, name, and I'm going to call this speed. So now this is called speed, and it has value between 0 and 100. And our character movement speed is actually set to a maximum of 600. So I'm going to change this maximum axis value to 600. So now our graph here starts at 0, ends at 600, and we can drop animations in here to determine what's going to happen at these different values. So I'm going to start with idle. I'm going to grab the idle animation and drag and drop it over here onto the 0 value. So now I've got this tiny little diamond here that is the idle animation, and we can see in the preview window that we're idling. Now I want to drag in the jog forward animation, and I'm going to put it in the middle bar here. I'm going to drop this here. And so now what you can do is test out your blend by holding shift and moving your mouse. So if I hold shift, this green crosshairs is going to move in the graph, and I'm previewing a different speed value as I move along. So if the speed was, say, 150, we can see in the preview window we're doing this really slow movement. And it's because your speed won't actually be 150 for long. As soon as you start walking, you're going to speed up very quickly from 0 to 300 and beyond. And so 300 is the value at which we're going to have a full jog, because I've dragged that jog animation and dropped it on the 300 value. Anything above 300 and we're still just jogging because there's no other animations in this blend. So what this is going to do is essentially, instead of jumping from idle to directly to jogging when we start to move, and then going directly back to idle when you stop moving, it's going to soften and blend these two together. So now instead of a jarring direct motion, we're going to get a blended motion into the jog and away from the jog back into idle. Okay, so that's the gist of the blend space, and I'm done with that. I'm going to close that. And now I'm going to go back to my animation blueprint. And we'll start here by making a new state machine. I'm going to right click, type in state machine, add new state machine. And the state machine is essentially going to control our animations based on what state we're currently in. So if I double click this, I'm actually going to first hook up the output to my output pose and double click the state machine. And we need to create some states. So I'll drag off the entry node here and make a state and call this idle/jogging. And to start with, this will be the only state. We'll create our other states for jumping after. For now, idle jogging is going to be the only state, and we're going to double click this and select what pose we want to output for this state. And what we want to output is our idle jogging blend. So this is a blend space player, and it's going to play that blend that we just made, but we need to put an input for speed. So that number that we were adjusting at the bottom of the graph we were previewing it by holding shift, we need to input the actual speed of the character now to determine whether we're idling, jogging, or blending somewhere in between. So to get this value, we're going to make a new variable. So I'm going to make a variable called speed, and I need to set the variable type to float. And I'm going to use control and drag this into the blueprint and plug it in here to this blend space player. Now we just need to populate this speed variable with the actual speed of the character, and this will be working just how we want. So to do that, I need to go to the event graph. And on the event graph, we have a default node here that you can drag off of called Event Blueprint Update Animation. So this is essentially like event tick. This is going to get called every time that the animation blueprint updates, which is going to be every tick. And what we can do is drag from this try get pawn owner, and I can say get velocity. This is going to return the velocity that our character is moving, and the return value is a vector. So if I split this, we can see we get an X, a Y, and a Z. It's giving us the velocity in all three dimensions. So what is our X velocity? What is our Y velocity? And our Z velocity? In reality, I'm going to right click, recombine this struct pin, and I want to flatten I want to get the total velocity. It doesn't matter if you're moving in the X, the Y, or the Z axis. How much is the total? I can do that by dragging off here and going vector length. So now I have this one flat float that's going to be a total of all this velocity. And I can get my speed variable that we made here, and I'm going to drag it out holding Alt, and that'll give me a set node, and I can set the value to this return value of our character's velocity. So on each update of the blueprint, we're going to update the speed value to our character's velocity. The only thing I have to do here is add a node to double check that we've got a valid character set up. So when you first run the game, it's going to try to run this logic before the character is even set up, and it could throw some errors. So I'm going to right click, I'm actually going to drag off of get pawn owner and just type in is valid, and I'm going to get this is valid node with the check mark, the question mark, and I'll just pipe this execution to go through only if it is valid. And if it's not valid, it'll just peter out and do nothing, no problem. As soon as it is valid, now this will be loading up the speed variable with our character's velocity. Okay, let's check it out. I'm going to press W to run, and this is working. We are officially fully animated for running around. So we got side to side, front and back. Okay, so the next thing to do is going to be to set up our jump functionality. So for jumping, I'm going to go back to my animation blueprint, and I'm going to go to the state machine. Double click that, and I need to add some more states. And I'm going to just select or hover over the edge of this idle jogging state and drag off of here, add a state, and call this jump start. And I'm going to drag from the edge of this one and add a state called jump loop. And I'll drag from this one, add a state, and call it jump end. And from this one, I'm going to drag back to idle. So this is the sequence we're going to go through when the character jumps. And the reason we need to break up this sequence into 3 different parts is because we don't know how long the character is going to spend in the air. So, for example, if you just jump from the ground and land on the ground, it might be a fixed amount of time in the air, sure. But if you jump from the ground and land on a ledge, you might land, you're going to land quicker. You're not going to spend as much time in the air as if that ledge wasn't there and you went all the way back to the ground. And same thing if you're up on a ledge or fairly high off the ground and you jump off of the ledge, you're going to spend a lot more time in the air before landing than if you were just jumping straight up off the ground. So because of having a variable amount of air time, we need to break up the animation. And so we're going to do jump start is going to be where you initially leap off the ground, the compression of the legs and the initial jump up. That's only going to happen once. No matter what you've jumped, you're going to start the animation one time, and then depending how long you're in the air, depends on how long you're going to loop this jump loop animation for. And then when you land, you're going to play this jump end animation, which is the character's feet landing back on the ground. And so same as jump start, jump end is only going to happen once. For every time that you've jumped, you only land one time. You jump up one time, spend some variable amount of time in the air, and then you land one time. So we need to set all this up. And we need to first double-click jump start. And the output pose for that is going to be this jump start animation. So I'll plug that in, and I just need to select here that we don't want to loop the animation. So set that to false. It's only going to play once. I'll go back to the state machine and go to jump loop, double click. And for jump loop, we're going to play the jump loop animation. And for this one, I can leave it set to loop the animation because we do want it to loop until we're done. We'll go back to the state machine, and for jump end, we want to play this jump end animation. And same as the jump start, it's a one-time play. I'm going to uncheck loop animation and go back to the state machine. And now I need to set up the rules, and the rules determine how we go around this loop. So how do we know we need to start the jump in the first place? So I'm going to create a new variable. So similar to using the speed variable to determine where we are in our idle jogging blend, we're going to use another variable called is falling. So is falling is a value we can get from our character, from the character movement component. And it's going to be true the second we leave the ground. So when you start a jump, even during your upward part of the jump, is falling will be considered true. And so we can use that value as the rule to enter the transition into playing that animation. So I'll double click here on this rule icon, and I'm just going to drag is falling into the result node here. And now we can enter this transition when is falling is true. We'll go back to the state machine. And now the rule to go from jump start to jump loop. So what we need to happen is jump start's only going to play one time, and then we need to play jump loop. And there's not really a need to define a rule here. That needs to happen every time, no matter what. So I can select this rule, and I can just go here and say automatic rule based on sequence. And if I check that, now as soon as jump start is finished, it's going to automatically move into jump loop. And jump loop is going to be the animation playing when you're still in the air. So if you're falling from, say, a high distance, it's going to be playing this animation all the way until you're no longer falling. And that's when we're going to play jump end. So for this rule to transition from jump loop to jump end, we need to be no longer falling. So I'll double click this, and I'm going to drag is falling. And instead of plugging it directly into the result, though, I'm going to drag off that, type in not. And now we get, it can enter the transition if is falling is not true. So that's when we'll enter the jump end animation. And we only need to play that the one time through and automatically move on back to idle. No matter what, as soon as your jump end animation is done, your legs are back on the ground, you're automatically moving to idle. You don't need a rule here. So we're just going to select automatic rule based on sequence. Okay, so now this is perfect. We should be able to jump as soon as is falling is true, and we'll be looping for as long as it's true, and we'll land as soon as it's not true, and we're back in the idle state. So now we need to load up the is falling variable the same way that we loaded up the speed variable. So I'm going to go to the event graph, and I'm going to drag from get pawn owner, I'm going to say get movement component. And from the movement component, I can drag off and say is falling. And that's going to return our character movement value of is falling or not. So I want to load up our animation blueprint variable is falling. So I'm going to drag that off with an Alt and plug the return value into there. And now every tick we're setting our is falling variable according to whether the movement component reports that the character is falling or not. All right, so that's it. We should be able to jump. The last thing we need to do is set up an actual input command to start a jump to actually happen. So I'm going to go back to the character blueprint, and I'm going to just right-click in a blank spot here. And I'm just going to manually put in a input here. So I could go back to project settings, and I could map this as a global binding, but I'm just going to shortcut that and type in space bar and get that keyboard event, and I'm going to right click and type jump and just plug this in. So when you press spacebar, it's going to run the jump function, and the jump function is essentially a built-in function to this character class that's going to give you, it's going to start your jump. And so you can adjust the jumping options in character movement, search details, type in jump, and we can see here our initial jump Z velocity by default is set to 420, and you have some air control 0.05, air control boost multiplier. You can select, whether you can move in the X, Y, or Z while in the air, etc., etc. Okay, so that's pretty much everything we need to set up. I should be able to press spacebar to initiate a jump, and that is going to let our animation blueprint know by way of the is falling function that it needs to start showing us the jump animation. Let's see if that works. Okay, I'll press spacebar, and not bad. So the only thing I'm noticing here is on landing, it doesn't really look like the feet get back to the ground quickly enough. It looks like we've stopped falling and then the feet go out, and it's not really natural looking. So I'm just going to speed up that part of the animation. I'm going to open up the animation blueprint, go to the state machine, and I'm going to double click jump end here, select the jump end animation, and under play rate I'm going to just bump this up from 1 to 1.5. So it's going to play that last part of the animation where the character puts their feet back down toward the ground. It's going to play that part just a little bit quicker, and hopefully that'll look a little bit more natural. Looking a little better. Probably could go even higher. I'm going to try, instead of 1.5, let's just go straight to 2.0. Okay, so that looks better. And of course you can fiddle with animation speeds versus play rates and everything else to improve how realistic your movement looks. Like, for example, how much ground I'm covering versus how many footsteps are being made, where the feet are planting. So this isn't perfect right now. It's definitely off a little bit, but it's really only if you're paying attention to that you're going to notice. If you're doing something fun in your game, you're not going to notice that your feet aren't planting exactly right on the ground, right? So one more thing I'm going to set up here is just to make this a bit more natural is I'm going to change this from basically a instant start stop. I'm going to put some acceleration and deceleration on the movement. So I'll open up the character blueprint here and go to the character movement component. And in the details, I'm going to search for acceleration. And I'm going to set the max acceleration to 750. And I'm going to search for deceleration and set that to 750. Now we'll take a look, and I should have a bit more natural start-stop action. Okay, now that feels pretty good on the start. It's a lot more smooth from standing in idle to jogging. The stop is still a little bit abrupt, and so you could play with deceleration or braking friction or other numbers like that to get a more natural feel. But essentially, this is the setup. We've imported our Mixamo character and implemented a third-person controller with basic jumping functionality. And that's basically the functionality that is included with the typical third-person template that you can access from the project browser, but hopefully now you have a better understanding of how it all works. So that's it for this video, and we'll see you next time.